Okay, we have some exponential expressions we'd like to simplify. So here's a few examples. First one, we have y to the fourth over y to the negative 7. So one thing we'd like to do, when we have a negative exponent, it flips it. So this becomes y to the fourth times, and this flips, so we have y to the 7th over 1. Now, with these two terms, the product of these two terms, we add the two exponents. So we have y to the 4 plus 7, y to the 11th over 1, or just y to the 11th. Okay, so that's our first example. So now let's try another. First I'll take a look at what's inside the parentheses. We have 4 to the 0, and anything to the 0 power is 1. So that just becomes 1. So we have w squared, all that to the minus 5th power. Alright, we have a negative here, so that flips this whole term into a denominator. So we have 1 over w squared to the positive 5. So we had a negative 5, but a negative exponent, we just flip it to the denominator, the whole term. So now, w squared, so a term, and then 2 in exponential power, you would multiply the 2. So you have w to the 2 times 5, or w to the 10th. And that's the second one. So now let's try a third. On these two terms, the parentheses really don't mean anything. It's just these three terms times each other. We have a negative times a negative, which gives us a positive, or a negative 1 times a negative 1 gives us a positive 1, which we don't really have to show. I'll put it there, just this once for simplification. Now we have a to the 4th times a to the 1. So a to the 4th times a to the 1 would be a to the 4 plus 1, or a to the 5th. And we have b to the 3rd. So it just ends up being a to the 5th, b to the 3rd. That's it. Okay, let's try a few more examples of exponential expressions. To do that, then, I'll erase these first three. We're just using the basic rules that we've laid out in a previous video, and we're just applying them to a little more complicated problems, but you just kind of have to take it piecemeal, step by step. So here's an example. We have minus 9 m to the 7th n 4th. We'll put that over minus 3 m to the 4th n to the 3rd. Alright, we've got a negative divided by a negative, which gives us a positive. So those go away. Let me change colors. We have a 9 divided by 3, which leaves us with a 3. We have an m to the 7th divided by m to the 4th. And we had a quotient rule earlier that when you divide one term with an exponent by the term with another exponent, you just subtract the exponents. So that becomes m to the 7 minus 4. And here we have an n to the 4th divided by an n to the 3rd. So that just becomes n to the 4 minus 3. So the answer is 3 m to the 7 minus 4, n to the 4 minus 3, which is 1, n to the 1. And of course a 1 is understood. We don't have to write a 1 here. So that's the answer to this one. Let's try another. Alright. We'll take minus 5 x to the 5th divided by 2 x cubed. We'll put all that in parentheses, and we'll take that to the third power. Okay, a couple things I could do. I could take this top term to the third and this bottom to the third, or I could resolve what's in the parentheses, and I think I'll do it that way. So we have x to the fifth divided by x to the third, which would be x to the 5 minus 3. So I would put minus 5 halves x to the 5 minus 3, or x to the 5 minus 3 just gives us x squared. And then I have to take that whole thing to the third power. Alright, so we have negative to the third gives us still a negative. 5 to the third gives us 125. 2 to the third gives us 8. And then x squared to the third would be 3 times 2, or x to the sixth. So that would be our answer to that one. Let's see, we'll try one more. One more example. Maybe we can fit it in the bottom of the board. I'm not really sure. So for this one, we'll take 7d to the minus 6 in parentheses times minus 4d to the minus 2, and we'll divide that by 2d to the minus 4. Okay, here it is. So what can we do here? Well, we can take the numbers, the constants themselves. 7 times minus 4 would give us minus 28. And then we have d to the minus 6 times d to the minus 2. We can add the two together. So we have d to the minus 8. And down below we have 2 times d to the minus 4. There's a couple different ways, directions I can take this, but I think what I'll do is I'll divide the 28 by 2, so I end up with negative 14. And d to the minus 8, subtract the bottom, because we're dividing this by this, so we end up with d to the minus 8 minus a minus 4. So minus 8 minus a minus 4. And of course that would give us minus 8 plus 4. So that resolves to just minus 4. And then we don't really like to leave those negative exponents in the top. So we'll take it one more step. We'll say minus 14, and we'll flip the d to the fourth to the bottom. So we took d to the negative 4 and we made it into 1 over d to the positive 4. And that's as far as we can take it. So here's a couple of examples.